Hello my viewers and learners, welcome once again to my YouTube channel Physics Hub 254. Today we have a revision question here coming from a topic, refraction of light. Refraction of light is a topic in Form 3 and it is a paper 2 topic. The question that we are going to do here is about a traveling microscope. Question on traveling microscope has posed a big challenge to majority of the learners. So today I want to make this question to appear more simpler and very interesting to you so that you may develop interest and be in a position to work it out and score the marks, suppose it appears in your exam. The question reads, a traveling microscope is focused on a mark on a horizontal surface. A rectangular glass block 30 millimeters thick is placed on the mark. The microscope is then adjusted 10 millimeters upwards to bring the mark back to focus. Determine the refractive index of the glass. So learners, this is the approach I'm going to give this question. Solution. I will sketch so that we get the pictorial bit of it. Suppose this is the horizontal ground, because a traveling microscope is focused on a mark on a horizontal surface. So let this one be the mark, this mark here. So the traveling microscope is above it, like let's say this point. This is the traveling microscope. So this is the microscope. It is used to focus this mark that is on the horizontal surface. Then we are also told that a rectangular glass block of this thickness, that is 30 millimeters thick, is placed on the mark. So let us place the glass block on the mark. This is the mark. So I'm bringing a glass block and I place it there. When that is done, the microscope is then adjusted 10 millimeters upwards. So instead of the microscope being along this line, the image of this was not brought to focus on the microscope. So the microscope had to be moved upwards. Suppose let's assume it was moved to this point. This is still our microscope. This was the original distance. It was from the mark on the ground, but because of this block, the microscope had to be raised up a distance equivalent to 10 millimeters. What has made this microscope to be lifted up through that distance is because the image of this mark was not brought into focus. In that, what happened, by bringing this glass, which has a thickness of 30 millimeters, the block gave this mark what is called vertical displacement. So a microscope was just focusing the image of this after it was given some vertical displacement. So the vertical displacement given to this mark on the paper after the glass is placed is the same as the distance through which the microscope is going to be lifted upwards so that this mark is brought into focus. So the distance here from this point to this point, which we are calling a vertical displacement, is the same as the distance through which the microscope was lifted or was adjusted upwards. So that is 10 millimeters. So at that point, learners, now we can now calculate the refractive index of the glass. We know very well that refractive index is given by real depth divided by apparent depth. But we don't have the apparent depth. We can get it. So our real depth is the same as the thickness of the block, that is the glass block. So we'll have 30 millimeters. The apparent depth can be gotten by the formula. Apparent depth is equal to real depth, is equal to the real depth minus vertical displacement. Minus vertical displacement. So my apparent depth will be 30. I subtract vertical displacement is the displacement that this object was given when the glass block was placed, which I've said is the same as the distance through which the microscope is adjusted upwards. So 10. This one gives me 20 millimeters. So at that point, I can now calculate my refractive index to be real depth 30, apparent depth 20, and therefore the refractive index is simply 1.5. It has got no units because it is a ratio of two lengths. So this one is the refractive index of the glass. Thank you for watching. For the new learners, consider subscribing, sharing, and commenting on our channel. See you next time in our next video. Thank you.